Hello students, in this video we will be learning real numbers, important 3-mark question. Questions are from the LBA, that is lesson based assessment, which is released by the Department of Education, Karnataka government. Now look at the first question. First one is prove that root 2 is irrational. To prove it is an irrational, first we need to assume it as a rational. So right, let us assume root 2 is rational. Since we are assuming it as a rational number, we can write root 2 in the form of P by Q, where PQ are co-prime numbers and Q not equal to 0. Co-prime means both the numbers should have a common factor as 1. Apart from 1, no other number should be there. Now shift Q to the LHS and you can write root 2Q equals P. Now square on both the side, square on both side. Now both the side we need to square, that is root 2q whole square equals p square. Root 2q whole square can be written as 2q square. Square and root will get cancelled and the square remains for q equals p square. Now we can see that if we shift 2 to the RHS, it divides p square, right? Therefore you write 2 divides p square and 2 divides p. After this, take p as 2c in equation 1. This is our equation 1. In equation 1, in place of P, write it as 2C. C is a constant that we are adding. 2Q square equals 2C whole square. 2Q square equals 2 square is 4 C square. Now we can divide it by 2 ones are to 2s are. Now 2 is left out here. If you shift towards the LHS, you can divide q square. Therefore write 2 divides q square and 2 divides q. Now you can observe 2 is dividing p square here and 2 is dividing q. So 2 is common factor. 2 is common factor for both P and Q. Right? We have assumed P and Q as a co-prime, but here 2 is a common factor for both P and Q. As I said, co-prime means the common factor should be 1. Apart from 1, we should not get any other common factor. Here we are getting 2 as a common factor, which means P and Q are not a co-prime number. So this occurs due to our wrong assumption. So here you need to write the statement, that is, this occurs due to our wrong assumption. So what we have assumed? We had assumed that root 2 is an rational number. So the contradicts occur due to our wrong assumption. Therefore, root 2 is an irrational number. So we have proved that root 2 is an irrational number. By using the same steps, we can also prove root 3 as an irrational number and root 5 as an irrational number. Okay, next question. Find the HCF and LCM of 510 and 92 by prime factor method. First, we need to find the prime factors of 510 and 92. The prime factors for 510 will be 2 2s are 4, 2 5s are 10, 255 divide by 5 will be getting 51, and again if we divide by 3, 17. So 510 can be written as 2 into 5 into 3 into 17. Now do the prime factors for 92. From two tables if we start, we will get 46. Again from two tables, 23. 23 is a prime number. Stop it over there. 92 equals 2 into 2 into 23. In both the numbers, the common factor, that is the highest common factor, is 2. To find the least common multiples, write the HCF ones and write the remaining number 5 into 3 into 17 into 2 into 23. If we multiply all the numbers, we will be getting 23,460. So this is the LCM. Now we need to verify it using HCF into LCM equals A into B. HCF is 2 and LCM is 23,460, and A and B, the two numbers are 510 and 92. Now if we multiply these two numbers, we will be getting 2 4s are 8 plus 1 9, 2 3s are 6, 2 2s are 4, 46,920. And if you multiply 510 and 92 also, you will be getting 46,920. If LHS and RHS are equal, which means the answer what we have obtained is correct. So follow the same step and solve two more questions, that is 336 and 54 and 26 and 91. Look at the next question. Find HCF of 135 and 75 by prime factor method, and then find the LCM of HCF of 135, 75 and 20. Okay, before solving, you need to read the question properly. First, we need to find the HCF of 135 and 75 by prime factor method. So start from 5 2s are 10, 3 remaining, 5 7s are 35. Start from 3 9s are 27, 3 3s are 9. Next 75. If we start from 5 tables, 5 15s are, next 5 3s are. 135 can be written as 5 into 3 into 3 into 3, and 75 can be written as 5 into 5 into 3. The highest common factor will be, you can see 5 is common, then 3 is common. Therefore, the HCF is 15. The HCF of 135 and 75 by prime factor method, we got 15. Now observe here, we need to find the LCM of HCF of 135, 75. What we have got? 15. We need to find LCM of 15 and what is the another number given? Another number is 20. We need to find LCM for 15 and 20. Start from 5 table, 5 3s are and 5 4s are. Again 3 1s are 3, 2 2s are 4, 2 1s are 2. LCM will be 5 into 3 into 2 into 2. 5 3s are 15, 15 2s are 30, 30 2s are 60. LCM is 60. Next question. Find LCM and HCF of 12, 15 and 21 using prime factor method. From if you start from 2 to 6 are 12 to 3 are 6, 12 can be written as 2 into 2 into 3, 15 can be written as 3 5s are 15 and 21 can be written as 3 7s are 21. So the HCF will be in all the three number, the common factor is 3. So the highest common factor is 3. Now least common multiple. To find the least common multiple, write the HCF ones and the remaining numbers into 5 into 7. The LCM will be 420. Use the same method and find the HCF and LCM for 6, 72 and 120. And that's all for today. I hope you have understood the concept well. If you did, don't forget to like, share and subscribe the channel for more learning videos. See you in the next video. Thank you.